So this is Notes 13, page 5. At this point in time, we've really pretty much covered all the material, but there are certain problem types that are multi-step that we just haven't seen it. Problems that put old ideas together. So they're not really new ideas. It's just practice with different types of problems. So here's a review problem. It's just bigger than most of the ones we've done. We're adding fractions, adding rational expressions. Notice I say state the restrictions, and my instructions perform the indicated operations. That means add and subtract. And simplify, which basically means, hey, if your final answer reduces, then you should do that. Okay. So suppose this is on your test. What should you do first? Well, you realize, well, that's 3 terms. And I'm adding, I need an LCD. So how do I find the LCD? Oh, I build the common denominator from factors of the denominator, not of the numerator, of the denominator. So first thing I really need to do is factor the denominators. So here's the first denominator, x squared plus x minus 2. No GCF. There's that quadratic term, the linear term, the constant. That looks like it comes from FOIL. So it looks like it's from a binomial times a binomial. Has to be x and x. Has to be 1 and 2. And because the constant is negative, I know it's 1 minus and 1 plus. So let's see. I need the middle term to be positive. So I need this to be plus 2 minus 1. Plus 2 minus 1 is positive 1. There you go. Now, a couple things. On the test, I want you to finish these problems. So when you're factoring to find common denominators, it probably won't be hard. The other thing is I don't want the common denominator to be huge for you just because of space and time. So sometimes, like if you look at this denominator, now x minus 1, you can't factor that, so that's the factor. And this denominator, x plus 2, you can't factor that, so that's the factor. You know, scoop it in parentheses. You would hope that at least one of these factors shows up over here. Because if it doesn't, you're going to have a huge LCD, and I really wouldn't do that to you. So some of these smaller factors here might give you hints how to factor the bigger denominator. All right, so I'm going to go ahead and put the x minus 1 in here and put the x plus 2 here. So now that I have prime factors in my denominators, I observe all the different types of prime factors that I have. I have x minus 1 and I have x plus 2's. So every different type of factor that shows up in any of the denominators that you're trying to add, for the fractions you're trying to add, those factors have to be in your LCD. Then you got to figure out, well, what power. The general rule is take it in the LCD with the largest power that you see in any of the fractions. Well, to the first power is the largest power that I see for the x minus 1. So it'll just be x minus 1 to the first. Same thing with the x plus 2. The largest power you see on the x plus 2 is 1. So that will be my LCD. So the next step is to adjust every fraction so that every fraction has this LCD. Now, the first fraction has the LCD I desire. I don't need to mess with it. Again, I think I've said this before. I always think, go fish. I got what I wanted. I don't need to mess with that one. I'm happy. This fraction has the x minus 1 factor, but it's missing the x plus 2 factor. So I can fix that. I can multiply top and bottom by x plus 2. Okay. Remember what I'm doing. X plus 2 over x plus 2 as long as x is not negative 2. And so that reminds me, I'm going to state the restrictions after we finish this. As long as x isn't negative 2, that will be 1. 1 times any number has the same value. I am not changing the value of this fraction. So, and then this fraction here, it has the x plus 2 factor. It's missing the x minus 1. So I'm going to multiply top and bottom by x minus 1. I am multiplying by 1 in a sneaky way. Now, before we go on, let's go ahead and state the restrictions. This is really, one of these steps right here is the best place to state the restrictions. These equals are going to hold, and these fractions will have meaning as long as I do not let the denominators be 0. Numerators can be 0. 0 divided by 5, that has meaning, it's 0. 5 divided by 0, meaningless. So I look, x minus 1, if I let x be 1, 1 minus 1 is 0. I better not let x be 1. And then I look at the x plus 2. If x is negative 2, that will be 0 because opposites add to 0. So I don't want x to be negative 2. So those are my restrictions. So as this string of equals I'm writing is going to hold as long as I don't plug in 1 and negative 2. Remember, the domain of the expression is just the different point of view. The domain is you can plug any number you want in for x, just don't plug in 1 and negative 2. It just tells you what you're allowed to plug in rather than what you're restricted. All right, so what's the next step? We have a common denominator. The purpose of the common denominator was to allow us to add the fractions, to combine this to one term. That's what you're doing when you're adding fractions. You're combining them into one term. But if you're adding, you add only the numerators. And to add, you need terms in the numerators. You need terms to add the numerators. Well, that's why I will distribute the 3 in the numerator. I am not going to distribute and FOIL that out because I'm wasting my time. I do not add denominators. So this will be 2x squared minus 20 over x minus 1 times x plus 2 plus, it's going to be 3x plus 6. And all right, if you want to do this, like in the middle of a problem when they get long over the LCD, I'm like, okay with that. Minus 4x, I'm distributing the 4x minus 4 over that LCD. So they all have the same denominator. And now, when fractions have the same denominator, you just add the numerators. But the one thing you have to be careful with, and this is the most common careless mistake where students, like, they do all these hard steps correctly, long problem, and then they blow it because they forget to distribute this negative. It's minus this entire numerator. Remember, this fraction bar acts like parentheses. So I would need to distribute that negative. So this is 2x squared minus 20 plus 3x plus 6 minus 4x plus 4. Since I'm getting near the end, I'm going to put in that LCD, x minus 1, x plus 2. See, I want terms in that numerator so I can combine like terms. So what I see, I have the 2x squared, and I have 3x minus 4x, so that's a negative x. And then I have negative 20 plus 10. 6 plus 4 is 10, is minus 10, all over x minus 1, x plus 2. So we're most of the way there. When you add fractions, sometimes you get a fraction that can be reduced, and we like lowest form. To reduce, we need factors. So once I've combined my like terms, when I'm thinking about reducing, that's where I might think, well, if I'm going to reduce, I need factors in that numerator. So let me see if the numerator factors. And if it doesn't factor, or if it factors but there are no identical factors to cancel, it's not going to reduce. So you could leave it this way, but I can't tell if it's going to reduce until I try to factor it. So no GCF, looks like it comes from FOIL, so it's going to be a binomial times a binomial. And let's see, I don't think it's 10 and 1, it's probably 5 and 2. So let me think, well, if I put the 5 here, that'd be too big. So try the 5 here, put the 2 there. Outer is 4x, inner is 5x. And I know the outer and inner will subtract because the last term is negative. So it's 1 plus and 1 minus. So this is going to work. I need the outer and inner to add to negative 1x. So I actually need the 5 to be negative and the plus 4x to be positive. So there it is. It's factored. Do I have any identical factors? Yes, I do. The x plus 2's cancel. And so this is 2x minus 5 over x minus 1. And keep in mind what equivalent expressions mean. This mess here is equivalent to this tiny answer here. So they're going to have the same value. So if I wanted to plug in 10 here, I could just do it here. I can do that in my head. That'll be 15 over 9, 15 ninths. So I know if I plug in 10 here, I'm going to get 15 ninths. It'll be a lot of work to get it, but I would get it. I'd much rather work with the simplified form. There's only 2 values where these 2 will not give you the same answer, and that's the restrictions. If you plug in 1 and negative 2, they are not going to give you the same answer. So you throw those values out for x because these equals do not hold. All right, so let's try the next one. Now, the next one is really not too bad. It's just a couple of steps is all. So you just got to mind your order of operations. This is all one term. So inside parentheses first. And I think I mentioned this in the earlier notes. I really haven't spent much time doing a simple subtraction problem like this. By the way, you might hear the phone. You can tell I'm at home. But don't make this too hard. So this is a pretty simple subtraction problem. We need an LCD. Both of your numerators are already in factored form. M plus 2 is your factor, M is your factor. And so the LCD, there are no common factors. It's just the product of the 2 factors. You just multiply the 2 factors that you see there. So that will be your LCD. So for this first fraction, it has the m plus 2 factor, but it's missing the m factor. So I multiply that by m over m. This fraction has the m factor, but it's missing the m plus 2. M plus 2. Okay, now I haven't finished inside the parentheses, but it's going to be this answer divided by this answer. And I know that to do the division, I'm going to change to multiplying by the reciprocal, but I'm going to need to look for factors. So I'm going to go ahead and factor this over here because I know I'll need factors and not terms. So m squared minus 4, that's the difference of 2 squares, m minus 2, m plus 2. And then m squared plus 4m plus 4. Okay, no GCF. Looks like it comes from FOIL. You might be seeing the pattern because the square root of 4 is 2. The square root of m squared is m. And if you take the 2 square roots, 2m, double it, you get 4m. So it would be m plus 2 quantity squared. But when you're reducing, it's almost easier to write it as just m plus 2 times m plus 2. Okay. Now, let's finish inside the parentheses. What's the tiny thing we need to do to make sure we don't make a careless mistake? It's minus this whole numerator. Distribute that negative through the numerator. And I'm going to try to do this in one step. This is m squared minus m, well, I'm going to have to factor that, minus 2. See how I distribute the negative over m times m plus 2. Now, once you've done what's inside the parentheses, you do not have to have them anymore. The parentheses are like priority markers. Hey, take care of me first. Well, I did that, and this is all one term, so these parentheses are not needed. You can have them or not. Here, I'm going to change division to multiplying by the reciprocal. And some of you might want to cancel the m plus 2 right away. Feel free. I'm just going to wait and cancel everything at the end. Okay. Now, looking at this, now notice I do have all one term here, just like I actually had all one term there before. I've got factors everywhere except this numerator. So let me factor that, and then I'll start canceling. No GCF, quadratic term, linear term, constant. Looks like it comes from a binomial times a binomial. It's got to be m and m. It has to be 2 and 1. It's 1 plus and 1 minus. And so that this one is minus, this one's plus, so that the outer is negative 2, inner is positive 1, so it adds up to negative 1. And then I have m times m plus 2 over m plus 2 times m plus 2, m minus 2, m plus 2. Now, before I start canceling, I want to talk about restrictions. When you have a problem where you divided, restrictions are a little tricksy. This denominator is now in the numerator, but because it was in the denominator at some time, you'd have to say, oh, I better not let that denominator be 0, so m can't be negative 2. Put that in my list of restrictions. Now the numerator became the denominator, so I need to add m can't be positive 2, okay? And then over here, you know, we don't see this a lot. Don't make this too hard. What value makes m 0 there? 0, so m can't be 0. And then here, that's a negative 2 that m can't be. We've already got that on our list. So those are the restrictions. Now I'm going to start canceling. There's a lot of canceling going on here. M plus 2's. Okay, these m plus 2's, all right, and the m minus 2's. So this whole mess boils down to nothing but m plus 1 over m, and don't you dare even try to cancel this m with that m. This m can be seen as a factor, but that m cannot. That's a term of this factor, the m plus 1 factor. So you're done. Don't cancel terms in the end and blow it. All right, so end of this page.